Okay, so as I was mentioning, if you have a benzene ring with two branches, you can number and name them in the regular IUPAC method. Okay, so for example, take a look at this one. We have two ethyl groups on carbon 1 and carbon 2. So this is 1,2-diethylbenzene. Here we have 1, 2, 3. So this is 1,3-diethylbenzene, and this is 1,2,3,4-diethylbenzene. Now, there is a special type of naming that exists, whereas basically what you do is you replace the numbers with a letter. So the numbers 1 and 2 are what are called the ortho position. So meaning instead of saying 1,2-diethylbenzene, you would say O diethylbenzene. So it's like you would literally do this. O. O diethylbenzene means exactly the same as 1, comma 2. So same deal here. So the 1 and 3 can be replaced with the letter M. Okay, that means exactly the same thing. Or you can have the numbers. Okay, 1 and 4 can be replaced with the letter P for para. So this would be P diethylbenzene. Now they don't have to be the same branch. One can be a methyl and one can be an ethyl. So you would just, of course, do that accordingly. So it could be P-ethyl methyl benzene. That just means the P, like these letters, all they're doing is changing the numbers. Like if I say something is an M, automatically that translates into 1 and 3. Okay, remember this is unique for benzene. Now, sometimes benzene can be considered to be a branch off. Okay, so meaning instead of being the parent, we can also consider it to be a branch. Now, when it's a branch, it has a special name. It's called a phenyl group. So here, if the parent is benzene, okay, so let's say this is the parent, we would use this name. Isopropyl, so see how it's 1, 2, 3 in the middle, isopropylbenzene. Or if we consider the propane to be the parent and benzene to be the branch on carbon 2, it would be 2-phenylpropane. Okay, so let's take a look at something. So let's say I had carbons like this, and then here I had, yeah, that's a benzene attached. Ah, oh my God. Okay, we're starting over. Okay, 1, 2, 3. Okay, let's say we did this, and slowly, slowly. Okay, not bad. Okay, this is as good as it's gonna get. So let's say we had something like this. So we have 1, 2, 3, 4, 5. So this would be a 2. So 2 dash phenyl. So phenyl, P-H-E-N-Y-L, automatically means, hey, benzene as a branch. And of course, this would be pentane because it's 5 carbons, all single bonds. Okay, so it's just another way. And this would go in alphabetical order just like anything else. So let's say I had phenyl, like a benzene ring, and then a propyl group. Phenyl would come before propyl. Okay, it would just be in alphabetical order. All right, so before I get to my last part, I want to just introduce you to some other branches. So we can also have halogens as branches, just because some of the worksheets you're going to be working on have halogen groups on it, but they're actually very straightforward to name. I'll give you some examples. All right, so let's say we had chlorine on this branch as a branch, right? So this would be 2-chloro. So you still, anytime you have a branch, you still need a number. But the name for a chlorine would be chloro. So this would be 2-chloro butane, in this case, butane. Okay, so chloro is chlorine, bromine is bromo, Okay, so that's a bromine branch. Iodine is iodo. So chlorine, bromine, iodine, those are the most common ones you're going to come across. I can't really... Oh, and fluoro is fluorine. Okay, so when you're doing the worksheets, you might notice like an alkane or an alkene that has a halogen on it. They're super easy. You just put in the number and then you would name them accordingly. And keep in mind, right, alphabetical order. So a bromo branch would come before a chloro branch, right? So alpha order. And same thing if you have more than one. So dibromo if you have 2 bromine, or trifluoro if you have 3 fluorine. Okay, so just be mindful of that. All right, so we're finally getting to the last part here. So isomers. There's 2 types of isomers, and actually after March break, we're going to be doing a lab based on this. So you guys are going to be constructing different structures. Constructing structures. Using model kits. So there's 2 types of isomers. We have something called a structural isomer. So essentially what that means is compounds that, or I should say molecules that have the exact same number of atoms, but they're rearranged to be different structures. So for example, here we have two different molecules. Both of them have 2 carbon, 6 hydrogens, 1 oxygen. In this case, it's constructed so that this one has an OH group. So if you add them all up, 2 carbons, 6 hydrogens, 1 oxygen. Whereas this one over here, still 2 carbons, 6 hydrogens, 1 oxygen, but it does not have an OH group. So this one here on the left is an alcohol functional group. This one is an ether. Don't worry about the names right now. What I just want you to be aware of is that a structural isomer is where you take the same number of atoms, but you just rearrange them to make something different. Okay? A geometric isomer is a little bit more unique. Okay, so first of all, geometric isomers only happen in alkenes. Okay, these are only possible when you have a double bond between the carbons. The reason why is because the trigonal planar shape of the carbon is what allows this to be possible. So when carbon is tetrahedral, or if carbon is linear, it's not able to twist. So geometric isomers essentially mean that the arrangement of the atoms are different depending on how the bond is twisted. So it can only happen in double bonds. So notice here, we have 2 types. We have a cis isomer and a trans isomer. So a cis isomer means you have the exact same type of branch on the same side. Okay, so think of like cis as the same. So let's imagine these are hydrogens and these are, I don't know, chlorines. If the 2 chlorines are on the same side, it's a cis isomer. You can even look at it this way, if the hydrogens are on the same side. Whereas if they are on opposite sides, it's called a trans isomer. So even though this is the same type of thing, like the same molecule, the way that this bond has been formed, right, is different than this. So it's just a different geometric formation. Okay, so again, don't worry too much about isomers right now. When we come back from March break, we're going to go more in detail. I'll probably your first day back, I'll do a little recap on isomers because we'll do our lab on isomers probably the second day of us returning. Okay, so please check the D2L posting to see what work you're doing. This Friday is going to be a work period for you to keep working on this hydrocarbon section. I'm also going to be posting some YouTube videos that will help further with the nomenclature of these alkanes, alkenes, and alkynes. Have a good day, everyone.